today's session, we are going to see how two matrices can be multiplied. So in the previous sessions, we have already seen how addition and subtraction can be performed on a set of matrices. And the condition which we need to focus on before attempting those operations. So similarly, in the case of multiplication, we also have to have one condition fulfilled before landing onto the multiplication process. So suppose I have a matrix A and it is of order m by n, and I have a second matrix B which is of the order of n cross O. So the condition for the matrices to have multiplication between them is, in the case of matrix A, the number of columns in matrix A should be equal to the number of rows in B. So if you see here, this m by n signifies the number of rows by number of columns. So in the matrix A, n is the number of columns. In the case of matrix B, n here is the number of rows. That means the number of columns and number of rows in A and B are equal. Therefore, multiplication can be easily performed. A and B, it is possible to have a product of these two matrices. But suppose if the order is such that the number of columns of matrix A is not equal to the number of rows of matrix B, then multiplication is not possible in such set of matrices. So this condition is very vital before attempting multiplication in the matrices. There's one more thing. Like in the case of linear algebra, the multiplication is commutative. Means 5 fours is equals to 4 fives. But in the case of matrix multiplication, this is not the case. In the case of matrices, A cross B is not equal to B cross A. This is not equal. We'll take some examples and we'll see how it is different, how you are getting solutions different if you are multiplying same set of matrices but their positions are changed. So two things you have to consider. First is the condition to fulfill, that is the number of columns in the first matrix should be equal to the number of rows in the second matrix. And secondly, you cannot have a vice versa multiplication. It should be in a proper manner. It should be in a proper direction. From which direction to which direction you are moving ahead. So let's take an example. Example 1. I have a matrix M which has elements 1, 2, 3 and 4. This is your matrix M. And I say, give me the value of 3m. Means 3 is a scalar value. It is a scalar number and this has to be multiplied to the elements of matrix M. So 3m means all the 4 values will be multiplied by 3. So 3m, this is equal to 3, and inside the bracket you have all the values 1, 2, 3 and 4. So this scalar value will be multiplied individually by each component. 3 ones are, 3 twos are, 3 threes are and 3 fours are. So this will be 3 ones are, 3 twos are 6, 3 threes are 9, 3 fours are 12. So this is the value of 3m. Okay. So this is a simple one. If you have any scalar value outside the matrix and you have to get its product, Simply you will multiply that scalar value individually with each component. Each values will be multiplied by that particular number and you will get the product. Now second example. Now I have a matrix M which has, I'm taking a square matrix so that you can easily understand. 1, 2, 3, 4. And I have a matrix N which has components 5, 6, 0 and 7. Now very first thing, what you have to see, you have to first get the order of all the matrices given. So in the case of matrix M, the order is 2 cross 2, means 2 rows and 2 columns. In the case of matrix N, it is 2 cross 2 again. Okay. Now, it is too much evident that the number of rows and number of columns are same here. So, multiplication can be easily performed. Now, M N is equal to. Now, how will you start multiplying? You will take one row. In the case of matrix M, this is row 1, row 2. And this is column 1, this is column 2. This row 1 will multiply first in the column 1. All the elements will be multiplied with row 1, then with the column 2. So how will you write it? I'll just note it down here. Now this is the first element, first row, first column, first element. So this one will be multiplied by 5. Okay. And in this first column of matrix N, the second value is 0. So you will do plus and you will pick this to this. Means it is 1 to 1. So 1 cross 5 plus 2 cross 0. Okay. First column is done. Now again same row with the second column. So what you will write here? It will be 1 into 6 plus 2 into 7. This row is done. This row 1 and 2, these both the values have been multiplied by column 1 and column 2. Now come to the second row, 3 and 4. So first 3 will be multiplied by 5 and 4 will be multiplied by 0. Now again this second row it will land on to the second column. So this 3 will be multiplied by 6 plus 4 multiplied by 7. So your Mn matrix, when you will solve, 5 ones are 5 plus 2 zeros are 0. So this will be 5 and here it will be 6 ones are 6 and 7 twos are 14. 14 plus 6 it is 20. Here it is 5 threes are 15 plus 0 it will be 15 only and here it is 6 threes are 18. 18 plus 7 fours are 28. So that will give you somewhere around 46. So this is the product of the matrix M and N. So what you have to do is, first you will pick the first row. The elements of that particular row will be multiplied by first column 1, column 2 or whatever is the number of the columns. Means individually one column will be multiplied and will be placed like this. And then you will add each of the components and then that will give you the resultant product of the two matrices. Okay. Now in the next session, we will see how Mn and Nm products will deviate or they will be same or it will be same or different. That we'll check out in the next session. So stay tuned for the next session.